Let's take a look at determining the area under a standard normal. Now this is not something you would ever do by hand. It involves some fairly complicated calculus tests. However, we have tables to assist us in the area. In your particular textbook, the table is found on those thick formula cards. They're in the way back of the book. They're kind of like a cock formula. You want to look at table number 5. It says standard normal distribution. It's also in the actual table section as well. So I would use the thick cards just because they're the easiest to find. If you want to use the actual distribution in the book on page A11 and A12. This is the formula, this is what the table looks like, 11 and A12. This is from a slightly different textbook, so you'll see that it's called table A instead of table 5, but it has all of these nice values on it. So how do we jump from a z-score to the area? Just to give you a visual, the z-score is calculated based on the formula we used in the last video, and then we want to find this kind of aqua blue area, or how much of the curve this occupies. And that tells us, remember, the proportion of response condition. For example, if I wanted to see what proportion of my students scored less than a 60 on their individual work, I would calculate the z-score based on the mean and standard deviation and find the area. So we're going to focus on finding the area. We're going to determine the area on the left of the standard normal curve first. Finding the area to the left is the easiest to do. You merely read the value off the table. So we just want to read the value straight off the table that corresponds to z equals and whatever our value is. Now when we read the area off the table, the first two decimal places, so in this case a negative 2.3, indicates the column. In the first column, it actually indicates the row we should go to. So I shouldn't say column. In the column on the left, it indicates what row. And the last decimal place indicates the column. So let's take a look at how this works. Remember the number negative 2.36, and I want to find the area. I'm going to go over to my standard normal table, and I'm going to look for negative 2.3. That was my first two decimal places. And so I find the negative 2.3. And then I look up for the 6. And I find the 6 right there. Negative 2.3 tells me what row to go to. The 6 tells me the column, and I want to see where these two meet. It's one of the reasons I'm a big fan of using, those cards in the back of the book. I even sometimes take a ruler out and put them on. All these numbers start to swim together after a while. So I kind of put the ruler or a piece of paper down so I'm sure I'm following the same row all the way out. So the area would be 0.0091. Or I'd have a very small chance, about a 0.9% chance of finding a person with that particular z-score. Let's try it again. Negative 0.3 tells me the row. 4 tells me the column. So we go over to our table. Negative 0.3. Well, I think I forgot I'm in highlighter mode here. There we go. Negative 0.34. So the negative 0.3 tells me the row. Oh. Negative 0.3. And the 4 tells me the column. There's the 4 column, and I want to see where the two of those meet. 0.3669, so that is the area to the left. And we'll last try z equals 3.45, remembering the first two tell me the row, the 3.4 row, and then I want the 5 column. And I do have to go ahead and I got to scroll down all the way to the positive numbers. Oh, buddy. I got to make my table smaller. There we go. All right, I think we're in business now. So if we look at this, we'll do this in purple. 3.4 is my first row, the 3.4 row. And then you have the 5 column, and they meet at 0.9997, giving me the area to the left of those values. So remember, anytime you're finding the area to the left or less than, you're actually going with the area right off the table. We want to read it directly off the table. When we go to the right, or finding areas bigger than, we have to realize the table always tells us the area to the left. I can find the area to the right quite easily by just subtracting my value from 1. So first I do need to find the area off the table. Negative 3.01. Negative 3.0 is my row. 1 is my column. We'll go over here to my chart. We'll find negative 3.0. Let's get the top in there. Match that up with the 1 and see where they intersect. 0.0013. Now that's not my answer because I want the area to the right. So I actually have to take a calculator out, which I highly recommend if you're dealing with 4 decimal places, and I want to do my subtraction. 1 minus 0.0013 is 0.9987. Now let's try it one more time. 1.75. I just want to get good at reading this chart. 1.75. 1.7 being my row, 5 being my column. Where do they meet? 0.9599. And remember, I then want to go ahead and do some subtraction. That is not my answer when I'm doing to the right. And my to the right value is 0.0041. The last thing we can do with z-scores is find the area between. For example, what proportion scored between a 60 and an 80? I would have to find the between value. And I'm going to do this by subtracting the two z-scores, the larger number minus the smaller number. Proportions and probabilities can never be negative, so be sure you're subtracting largest minus smallest. So let's go over to the table and find the z-score for 2.05. .05 looks to be 0.9798. Negative 2.05 will go up to the negative values. Looks to be 0.0202. And we can go ahead and subtract those to find our area. Now just remember biggest minus smallest, and you'll be fine. 798 minus 0.0202, 0.9596. And now you've done all of your calculations with z-scores.